Hey, I'm Major Hovey. I go by Slate. I'm a B-52 pilot. This jet is from Edwards, and here we are at EAA Air Venture 2024 in Oshkosh, Wisconsin. So this is a test aircraft. It's a tagboard flyer, so its history is kind of interesting. A lot of the test jets we have a pretty interesting history behind them. But this one actually flew the D-21 ox cart way back in the day, and it's a great platform. You can hang just about anything off of it, even if it's not destined for the B-52, right? Like the Buff wasn't the original idea for the ox cart, but it's a great platform to strap it on the wing and fly it for the first time, so we can figure out how it flies and you know, all of its characteristics, test it out before we actually go strap it to something small, super fast, or whatever it's destined to go do. So yeah, the B-52s out of Edwards were a little bit different. We come from Air Force Materiel Command. So Materiel Command versus Global Strike Command in some of the previous videos that you might have seen. This jet is modified for tests. It's completely combat capable with the add-ons that we need for telemetry, sensors, and monitoring of our test equipment and the aircraft itself. So if you want to walk around, we'll just start pointing out kind of some of the upgrades that we're expecting for the B-52, and then some of the test unique items. The unfortunate part with this particular jet is that we'll see some panels and I'll describe what goes there. But this one's actually getting ready to go to Tinker Air Force Base for its periodic like in-depth maintenance. So one of the beautiful things and why the B-52 is going to stick around for so long is that it gets this periodic maintenance. Every jet in the Air Force does, but they take the metal off of it, they can inspect the bones, repair what they need to, and put it all back together, which is amazing. And that's why this is going to stick around when some of our other strategic bombers are probably going to end, or approach their end of life a little bit sooner. But this one's got the longevity to keep going. So, Materiel Command, I mean, my main job is really to deliver the warfighter the tools that they need to get the job done. So we're going all the way from the research and development to the tests and execution so that we can deliver it. And then we're also focused on looking at the sustainment piece, right? And the B-52 is a great example of getting it right way back in the day, where we've been able to sustain it up to now, and then we'll be able to sustain it up, hopefully 2050 and beyond, so who knows. We're right at the nose of the airplane right now, so underneath the nose cone, just like many military airplanes, we've got a big radar under there. And this is a strategic radar. Originally it was designed for low-level navigation and the strategic nuclear missions. So being able to pick fixed points on the ground and tighten up that navigation solution without the aid of GPS or a long time on the ground spinning up my INS or something like that. So it's been great, it's done its job, and the B-52 as a whole is still a super capable platform. It's able to do the job that we want it to do really well. It holds down a lot of different mission sets. The issue that we're having with it is that some of the components on the aircraft aren't maintainable or sustainable anymore. So the engines, the radar, they don't make them anymore. The companies don't even exist. So we're having to remanufacture, refurbish, or pull stuff out of the boneyard in order to repair and maintain the jets that we've got. So the idea is that we want to get it to 2050, and we want to take the aircraft and put something new on it, but really we're looking at form, fit, function replacement, right? I don't need brand new capability. The jet's already doing its job well. I just need to put something on it that has a company behind it, a supply chain, all the parts available, so that I can keep it going up until that date. So one of the things we're changing is the radar. We're going to put the F-18's radar up on the nose. So we'll actually lose the chin pods. The low-level mission is not necessarily our bread and butter. We still do a little bit of it, but we don't necessarily need the TV cameras that we've got out on the chin pods. That'll increase our top speed just a little bit back to where it used to be with previous models of the B-52. Right now I can do 0.84 Mach. I'm hoping that we can get up above 0.9 Mach, so somewhere 0.92, 0.94, something like that with the chin pods off. But that's a big change for us, especially when it comes to the inside of the airplane. It's all designed, you know, CRT screens and many upgrades over the years with all sorts of different systems that are kind of one-off. So I've got a system here, and they kind of talk to each other. But with the radar, I'm going to have to add a lot of processing power, and I'm going to be able to integrate that with my targeting computers and my navigation computers and all that. From, you know, an F-18 radar, it's much newer, and so I'm going to have to change a lot on the inside of the airplane too. But let's see, let's just walk around the left side like we normally would for a walk around. We'll talk about some of the other stuff on the airplane. Big crowds here at EAA. We've been rock stars, and you know, if you want to pan for a second, we're right in the center of the EAA's ramp, which is awesome. So we get to be front and center of the show this year, and we're the first thing people see as they come up that main drag. It's been quite the honor, quite the pleasure to get to talk to all these people. So it's awesome. Up here, before we go in the wheel well, this is our mounting pylon, and I don't know what you all have seen before on other aircraft, the B-52s that you've seen, but we can add a few different types of pylons onto this mount right here. So the normal one we call the HSAB. It's the Heavy Stores Adapter Beam. It has mounts for all of our conventional weapons. And then we also have a nuclear pylon that we can add, you know, nuclear weapons to. And in addition to that, we still have in the boneyard and other places some other pylons from, you know, past weapons and past programs that we can kind of retrofit for whatever we need to put up there. So this orange panel right next to it, that's test unique. So anything orange on the airplane you see, it's not a production part. So there's a little panel inside of that panel, and the reason it's there is so that I can add a camera to it. And that's one of the beautiful things about the B-52 is that I can see my weapon out on the wing. I can get it out in the airflow on that pylon, and then I can put a camera on it and I can see the dynamics. And you know, a lot of times the brand new weapons, they, instead of boom boom, they've got some computers in them and all sorts of different types of telemetry and that kind of stuff. So we're figuring out the dynamics of the weapon before we ever let it leave the airplane. And then once we leave the airplane, it's usually got radios and that kind of stuff. So we'll retransmit that information to ground stations that are you know, looking at all the data and recording it all, and then we can post-process and figure out what we can do better. So so that's where the cameras go. There's a few other places on the airplane that would have cameras mounted to them, both on the chin. You can't really see it here, but through the crowd, there's a little bit of orange in between the antennas over there. So we'd have cameras pointing all over the place. As well as typically, if we're actually doing a release, we'll have fighters or somebody on the wing. Usually I need a two-seat, you know, pointy nose airplane, so that I've got a pilot and then I put a photog in the back, and their job is to take video of the release as well. Sometimes they you know, go chase it as well, which I imagine is pretty fun. But inside the wheel well here, see if we can find some room. We'll sneak in here.
Oh yeah, I'm sorry. Get out the way.
Yeah, it's all good. So this airplane, being a test bird, has what we call a bunch of orange wire. It's got all along the edges here, and then nothing too special, but all sorts of different connectors and random runs of these orange wires. And what that's doing is sensing all sorts of different parameters from the airplane, and it's able to take those into a computer where, as you panned up here, you probably saw some cables as well, right? So my aircraft is not digitally controlled. For the most part, the control yoke, the throttles, everything runs a cable out to the engines or the control surfaces that actuates a valve or, changes the fuel control unit, just like a motorcycle's clutch or throttle lever. So what we've done with this airplane is been able to instrument all of those different pieces so that my control room and my engineers have all of that data for the parameters of the airplane, in addition to whatever else is on it if we're testing a weapon or something like that. So that's kind of what's special in here. Nothing too crazy to see, but you can see by the size of some of the orange bundles that we've done a lot of little instrumentation all the way along the jet. Right here we'd have a big rack of computers as well, so that's taken out for its periodic maintenance here coming up in the next month or so. But that's where a lot of these bundles are going to connect to. And we sneak out here these beautiful TF-33s, pardon me. These engines have honestly done a great job. They've been super reliable, they've been maintainable, and for the technology at the time, they've done an awesome job. The downside is that, like we talked about, they just don't make parts for it anymore. So we're having to remanufacture and redesign a lot of components for those, and so we're going to replace them to get this aircraft into the 2050s and beyond. So we're putting Rolls-Royce F-130s on the aircraft. Rolls-Royce is doing all the engines. They've never potted them before, so that's one thing that we're doing a lot of testing and design work for. They have been mounted on the fuselage of some other aircraft, but they've never been right next to each other. So there's a lot of dynamics with that we're researching and doing a lot of design for. The other piece is that they're slightly higher bypass turbofans. They're different shape, so they can't just go right into the nacelle that we've got. Boeing is doing our nacelle design and the integration on the pylon. So we're going to change this whole pylon. The engines are actually going to be a little bit bigger and a little bit higher when they finally get mounted on the airplane. Of course, with new engines, engines drive my hydraulics, my electrics. They're what I get pneumatic air source from as well. So all of that's changing as well. From inboard to the engines is all going to be new. And then we'll use some of the old systems and kind of plug into them in the body of the airplane. So new engines, very exciting, and the awesome part too is that with new technology, we're gonna get the benefits from that, right? I'm not really interested in improving the capabilities of the airplane at this point, right? Obviously, I would like to, but it does its job so well, I don't need to. I'm just trying to get that new engine on the airplane and have something that's maintainable. So form, fit, function replacement, like we talked about, we're going to put a new engine that does almost exactly the same thing on the airplane. I know that one of the questions I keep getting here at the air show is, why not 4? Why 8, right? Well, the original aircraft was designed for 8 engines, and we've done the design studies to look at, hey, would it make sense to put 4 on here? It's quite a challenge out on the outboards with the sagging wings and only having spoilers for my control surfaces for roll. Pod scrapes and that kind of thing would be probably a lot more danger. There's also structural concerns out there hanging one big engine for any sort of vibration or something like that. So the 8 configuration is what we're sticking with, and it's gonna still look like a buff. So yeah, that's good stuff. I'm not sure if there's a whole lot more orange panels out here, but The other thing that we're doing, if we turn around, is some new wheels and brakes. So exactly the same reason, exactly the same situation. We're going to put new wheels and brakes on the aircraft, but they're going to be pretty much exactly the same performance. I really can't stop a whole lot faster than I did before because of the structure of the airplane, can't handle it. But I need something that has parts and supply chains. As a tester, I'm very excited about that. It's pretty dynamic testing new wheels and brakes because you've got to get them to the limit, and that's my job, is to figure out how to slowly approach that limit and probably go beyond where I would expect an operational crew dog to end up. I don't ever want him to show up in a spot in the envelope where he gets surprised, whether it's on the ground or in the air. I want to have been there first. So that's kind of what our job is to find those limits and the edges, the corner cases. So if you want to sneak through the bomb bay, we can go in there. There's just a little bit more orange wire. So you can see a little bit more orange in here as well. Right there we've got some mounts for some more cameras and all sorts of new wire. And then one interesting thing along the bomb bay here, we've got a little bit farther down, this wire right here that's plastered to the door is called a RERAD antenna. So if I have something in the bay and it has telemetry on it where it's trying to send its signals and its dynamics and all that kind of stuff to a control room on the ground, with the bomb bay closed, it's really hard for it to get its signal out. So it's transmitting, this is picking it up, and then the aircraft both records it just in case and then sends the data from the aircraft itself from antennas on the aft end of the airplane. Some of the other programs we're working on that I'm pretty excited about, we've got quick strike mines. So we're doing the 2,000 pounders with the wing kits. And then working with the Navy on that to hold down the mining and deterrence part of their mission. The B-52 has a big part to play in that. We haven't done a whole lot with new standoff weapons or anything like that. We're doing some software mods to make it easier for the crews to deal with a dynamic battle space. So there's a lot of systems that are getting changed that aren't necessarily visible that increases the capabilities of the aircraft in the future. You probably heard about hypersonics, so the B-52's done a lot with that recently, and we don't expect that to stop. So we're looking forward to the future for hypersonics. I can't talk a whole lot about what we've done and what we've seen, but the B-52 is a great platform for that research and development. And that's really what we've been doing in that realm, right? We're not necessarily fielding weapons, but we're figuring out how everything works and doing a lot of that research piece. So that's a lot of fun, figuring new stuff out and doing stuff nobody's ever done before. So whenever we do a new weapon, whether it's hypersonics or the quick strike mines that we're talking about, we will push past the limits of the airplane to, like we said, to make sure that we're going past where a crew dog's going to end up. So one of the ways we do that is we put a fighter out on the wing, and he's not only video if we're going to release, but he's also a safety chase for us. The instruments in the airplane, we talked about, it's not really a digital airplane. There are some computers in it, and we do have an air data computer, but a lot of that stuff is not super accurate because of the airflow around the airplane when I get super fast. So that's why there's a 0.84 limit. It's both for controllability, but it's also because my airspeed kind of just goes haywire. Based on the shape of the airplane, I get local supersonic flow, and the pitot tubes on the airplane just can't figure out how fast we're actually going. So the data I'm getting is inaccurate. And so I'll put a fighter on the wing, and I'll go past that point so that I get a little bit faster, a little bit more dynamic pressure, on the weapons, and then make sure that that the release goes okay. This airplane will go all the way up to 0.91 Mach right now. So, and we'll push her all the way up there with the fighter calling off our Mach every 5 seconds or so. 0.9, 0.9, 0.9, 0.91, 0.91. You know, so that's pretty fun. I don't have a whole lot else for you guys. The test airplane, like I said, great platform to do all sorts of stuff, not just for us, but for other customers out there. And lots of sustainment upgrades coming to the B-52 in the future to keep her trucking until 2050. Here's hoping she'll be in the flyover ceremonies for a few of her friends. So.